Okay, so my name's Greg Burgess. I'm the development manager for the high performance computing team back in Redmond at Microsoft. HPC team is now part of Azure, or Windows Azure. So let's just dive right in to what we're going to do here. This nice little template they gave me does all these awesome animations. So first of all, who's going to benefit from this talk? So developers of computational intensive applications or apps, or also developers of computational intensive services that you might host in the cloud. And then also applications that on a desktop need additional resources, and making it so that you can use Azure, Windows Azure, to help speed up those applications. And we'll go into some examples of what some of those are. Topics. We're going to talk about what the Windows Azure Scheduler is. We're also going to talk about using the Windows Azure Scheduler and the HPC, or high performance computing, runtimes. And I'll get into a bit of detail on that. And what you're going to leave with is how easy it is to build computational intensive services with Windows Azure at the end. Looks like we scrolled off a little bit there. Okay, so what's the problem? Some apps run too slowly on a single computer. Splitting them up into chunks and then running those chunks in parts on multiple computers can speed them up. And doing this effectively requires using a compute cluster. So there's two parts to that. So one is like tools to create and manage that cluster. So And HPC, or high performance computing, originally was or is still, not just originally, is a system or a tool, a set of applications and tools for building large on-premise clusters of computers. High performance computing has gone up to, let's see, we've done a 2,000 node system with 32,000 cores. So that's one Windows cluster. That's the scale we're capable of. And then once you do get all those machines up and running, it's actually effectively running work on those. So I'll just do a little bit quick animation here again. So, what does high performance computing have in common with Windows Azure? We can use, and we've got two little pictures here. One's of a traditional, cool-looking supercomputer. And another one is kind of what Windows Azure looks like, a bunch of blades sitting there. You can use both to solve large computational problems. HPC is sometimes best described as a massively parallel work that you want to go do out on a system. There's both things where you're doing what we would call embarrassingly parallel, which is running lots of little steps. There's tightly coupled applications where the application itself is split across lots of machines. Those machines are talking to each other quite a bit. And then the last one here is what we would call data analytics, which is something that's new. And that's where you've got large amounts of potentially unstructured data and being able to split that across a lot of different machines so you can do much faster queries against that data. Oops. Okay. So some example workloads that can use a cluster. One that comes up pretty quick right now, if anybody's seen some recent Disney movies, Pixar. So digital media rendering and encoding. Rendering single frames for especially a high fidelity movie can be an hour to 2 hours to even a day or more than a day for a single frame. If you think about movies got anywhere from, depending on format, 24, 30 to 60 frames per second. So 24 being traditional, IMAX being 60. At 24 frames, I think I did the math on this. It was something like 1,400 frames per minute. Yeah, if I do the math, I'll have to go back. But it's thousands and thousands and thousands of frames. And then to toss into it, because everybody thinks 3D is really cool these days, not only do you have to do one frame, you have to actually do two for both eyes. So the amount of computational work that's involved in putting these films together is pretty big. But it's also not just these big films. There's so much digital animation that happens, or digital rendering, in all facets of media now. A lot of television shows where you see they're out in New York doing this big cool scene. The reality is they're probably on a sound stage, and they've just got a little part, and then it's a big green screen in the background, and they put everything on top of that, and a lot of stuff. So there's a lot of rendering there. Financial and insurance risk calculation. These are types of things where you're doing a lot of Monte Carlo type simulations where you've got a certain, say, spreadsheet, could be Excel. You've got a calculation, a large calculation that takes some time to accomplish, and you want to run that across maybe millions of different iterations where you're just tweaking different variables in there to try and zero in on a good solution. And that's both for financial, and then insurance company does a lot of that relative to things like the flood maps or earthquake probabilities, et cetera, et cetera. So engineering, modeling, and simulation. If you guys read my bio, I like sailing. One of the things that all the America's Cup people are doing right now is doing fluid analysis, or the dynamics of how the fluids move over the structure of the hull, but then also how the wind goes through the sails. They're doing that all on, most of it now on clusters, using computers to simulate that. Additionally, most crashing of automobiles right now, a lot of those tests are happening in computers again. Boeing doing the analysis of the airflow over the wings of the 787, but even the 777 and whatnot, all that again in computers. Let's see, Ferrari doing, what did they have? It was, well, they do a lot of stuff, but one of the interesting ones was they were doing a parametric analysis across, with a tightly coupled application of the flow of fuel through a pump. So quite interesting stuff. Computational life sciences. In fact, I think we've got a demo of that. We're going to do a BLAST demo, right? Yes. Why not? Woohoo, we're going to do BLAST. So that's a lot of, you hear about all the stuff we can do with genes and matching and whatnot, so there's that. Additionally, a lot of protein folding around drug analysis and such. So Earth Sciences, interesting when you want to start looking at like earthquakes, interesting from the oil and gas industry, so they do a lot of analysis right now based on the sensor data that they get back. And then last is, I'm going to call it data analytics. Some people might call it big data. I kind of changed that around a little bit more because it's not just big data, but it's really how you can look at that data. In fact, a colleague of mine sitting in the back, Aid Miller, he's got a talk specifically. I'm going to go reference my phone here. Today, it's 4:53, and it's in room 2010B. And what time is it at? 2 o'clock. 2 o'clock. So he's going to go in depth on that. It's a brand new technology that we have coming out. Next slide. Okay. So I want to talk a little bit more specific about what's happening in some of these applications, and then we're going to go into a demo because slides are kind of boring. So this is what we're trying to look at here is an embarrassingly parallel application. And this is where what we've got here on the left side is me. That's my stick figure. It's the best I could do. And I've got my laptop. And what I'm doing is I'm submitting some work up to a cluster of computers. So in this picture here, I've got 9 computers. And then in that box, or that little pink box, is application logic. That's an actual executable of some sort. And what's happened is I've submitted that work, and that work most likely consists of hundreds, if not thousands, or hundreds of thousands of calculations that we want to have run, and they can all run independently. So this happens up on the cluster. Potentially, I might interact with some of those things as they're running, and then after all that work's done, we get those results back. Okay? So each one of these things that happened in those computers was just completely execute on its own. Next is what we'd call a tightly coupled application, or MPI. MPI is a standard in the high-performance computing world. It's known as the message passing interface. It's a way to very quickly exchange information between 2 different computers, typically over a technology called RDMA, and that stands for Remote Direct Memory Access. And what happens here is it's really the same executable, or I should say multiple instances of the same executable running across that cluster. And these nice little black lines that I put on here are kind of trying to illustrate that they're exchanging data back and forth across these high-speed interconnects. And when I say high-speed, and this is not in Windows Azure today, this is on-premise, but we'll have this in the not-too-distant future in Azure, is you're getting upwards of 10 to 40 gigabits per second. So you can essentially copy like a whole DVD a second. And our latency between those nodes in an on-premise cluster is usually in the single microseconds. Up in Azure right now, it's a bit longer. But again, coming down. But it gets to the point that you're pretty much, it's almost like remote DMA. So very, very fast. And yeah, so we submitted the work. Now we got our results back again. So in the data analytics side here, a little bit of a difference. Now I got these little white lines. They're not black anymore. But what's happening here is that each one of these nodes has pieces of the data on it. And it's both reading and writing out of the hard drives in each one of those nodes. But the nodes are also potentially talking to each other. Actually, I shouldn't say potentially. They are talking to each other and exchanging data as they work through analyzing all that information. And again, Aid will have a talk today at 2 p.m. Where he will go in great depth as to what we can do with that. All right, so, all right, enough slides. Let's take a break for just a second. So we're going to get out of here, and we're going to go to this nice window I've got set up here, and we're going to do a quick little rendering problem. So let's go ahead and bring this up. So what I'm connecting to here is a we're going to boost the size of that up a bit. There we go. All right, so this is a website that's running up in Windows Azure that Wenming worked on. And this website will do a rendering of, what's it going to render? It's going to render airflow over a model. Of a car. And the car, actually, it's going to spit out a movie at the end. The car looks kind of like what a Cub Scout Pinewood Derby thing with a rocket on the back of it. It's a CO2 car. Okay. So let's go ahead and I put my password in. And start rendering. I hit it. Boom. Okay. So again, this is this thing running up in Windows Azure. And how many compute nodes does this one have? 8 compute nodes. All right. So we've submitted the job, and it's running. Now, that's kind of interesting and all, but I want to show you another version of this while it's now it's running, blah, 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 job progress. We have another version of this application while that one's running. And what we'll do is we're going to submit from Windows Phone. For it to start up here. Boom. All right. So here, we'll do it from the phone too. The phone's kind of cool. Second. If you look really quick, you'll see what I typed in. Got to change that password in about 50 minutes. Okay. So now we're waiting for some message to come back from this job. And I'm skipping around here just a little bit because now I want to go back over here. And I'm going to go here, and we're going to go to Job Portal. So we're going to continue right along. So I don't have the right certificate installed in a place, but we'll just kind of ignore that error while this comes up. Okay, so what we've got here is this is job 59, and it's running right now. So this is, I've connected to the HPC job portal, and it's running up in this Azure subscription. So it's the front end right now for this Azure subscription. And you can see that we have this job that's running. And I'm going to move around a little bit quick because this kind of happens fast. But we can see how the frames are now starting to actually come back to the device here. If I go over here and I click on this job, and wait for a second, we can see that within this job, we are doing a parametric sweep. It's going to render 40 frames, and it's basically just calling this command script, which is going to go get some data out of blob storage. It's going to call an application that's up inside the deployment. It's going to render it. It's going to take that resulting frame, put it back in storage, and then at the end, it'll put it all together into a little film. Let's go back to here. We'll see that it's got 27 running right now, just clicking right along. Okay, so let's wait here for just a second. Okay, so now it got through the rendering, and it's encoding it. And now it's going to download it. And it's only showing 40 frames, but what you can see on here is the, let's hit play again. You can see how the air's going across the surface of that. Now, since we did this kind of quick, I have a higher resolution render here, which was also done up on Azure. Whoops. And we'll just tell this to keep repeating. So this was done using the same software, right? Except we let it run a little bit longer, and then we spun it and whatnot. This isn't something I can do in 2 minutes here. It takes a bit longer. And this is a real car, and you can see how the airflow is going over that. So why don't you Wenming can turn his mic on and talk a little bit more about how this was done.
Right. Well, good morning. My name is Wenming Yi. I'm a technical evangelist with the developer platform evangelism team. I specifically work with the HPC team on applications and the porting of HPC applications. So the way this particular example works is that we first ported a piece of software called OpenFOAM. OpenFOAM is a CFD simulation software which runs in parallel as well as single-threaded. So it's essentially an MPI program. So the way it works is that as the simulation is running, we did a recording of really a data dump of each of the frames of the actual physical car moving through the air. And we save them as RenderMan files. And the RenderMan files can then be uploaded onto Azure to be rendered at a very high fidelity. So since this is an embarrassingly parallel problem where each unit of work is essentially the frames that we're rendering, it's a very good workload for Azure. And that's basically how this whole process worked. Back to you, Greg.
All right, cool. That's a pretty nifty demo. Okay, so let's go back into slide mode first. Oh, go back here real quick. We'll see that if I refresh this, boom, yeah, retry. If we refresh this, finished running. It still thinks things are running. Ooh, bug. Okay. Interesting. All right. Yeah. I refreshed it. We'll go all jobs. Let's do it this way. There we go. So we can see everything's finished, which was great. So, okay. So let's skip back over to good old PowerPoint here. Boom. All right. So HPC server makes this easy. So again, now I'm stepping back a little bit from Azure to talk a little bit more about what HPC server is. And an HPC server, our head node, that's where the server part is running on the left side of the screen. And what it's doing in a traditional cluster is taking care of actually managing those nodes. Then it's letting a client schedule jobs, and then it will take the HPC server will take that work and control it and make sure it's running appropriately out on those clusters. So from a component point of view, we've got three main areas of what we've been shipping in HPC, and HPC's been shipping now about 6 years. We're on our third major release. In the past year, we've had 2 supplemental releases are called Service Pack 1 and Service Pack 2, which added some Azure support for HPC to burst up to Azure. Our SP3 release, which will be coming out later this year toward the end of November, December, I'm not firm on a date yet, allows you to use these components up in Azure. So looking at the slide here, what we have are the 3 main areas: our scheduler, our distributed runtimes, so parametric sweeps, something called cluster SOA. I'm not going to touch too deeply on that. MPI, linked to HPC, which is the data analytics, which, again, Abe, put my plug in. He'll have a talk on that later. And then Excel, we have a way where we can take some companies do parametric sweeps of Excel spreadsheets, or they want Excel to call out to a calculation. We can host those up in a cluster. And then on the far right side is the system administration part, which is where we're looking at cluster deployment, monitoring, diagnostics, and reporting. So if I go to the next slide here, these are the components that we have in the SP3 SDK for Windows Azure that comes out toward the end of this year. And I've highlighted what we're moving up there, which is just the scheduler and the distributed runtimes. Now, I did a little trick. I renamed Job Scheduler to Azure Scheduler. It's really just a rename on the slide. For all those things that are in those two boxes that are highlighted there, that's the exact same code that we run on premise. So there's a couple little changes in it where it says if I'm in Windows Azure, do one little thing differently, or if I'm on premise, do something else. But 99.8% of that code is exactly the same. So that means that you're getting things with the HPC job scheduler, such as the same exact API. You're getting all the great policies. So we have a really good first come first serve batch scheduler with backfill and grow shrink and blah blah blah. All of that stuff that people are used to using on premise to build compute clusters is now available to be hosted within your own deployments. I did do one other little trick too. Is I dimmed Excel. Technically, Excel does work up in Windows Azure, but our licensing people haven't quite caught up with the prospect of running full-on Excel in Azure. So I'm not quite, and that's hopefully going to happen in November as well. So there's this little language in the EULA, and I don't like making lawyers get upset, so we're just going to kind of pause on that for a bit. Okay, so now let's talk a little bit more about what happened in that rendering sample that we showed. Here, I've got this little laser pointer I'm supposed to use. Woohoo! I'm dangerous with these things, so watch out. All right. So here, this is a Windows Azure deployment in that gray box. So this is being hosted within a subscription. So I have a subscription. How many people in the room are familiar with working with Azure? Great. Okay. So deployment, subscription, all that. If you have any questions, we'll do some Q&A at the end. But if it's really you want to ask it, go ahead and jump up at any time on this. So we essentially built like two different roles inside that subscription in order to make this work. The first was a front end here. Okay. In that front end, I did a little trick here. I actually stacked it. So with Azure having fault and update domains, we have two instances of that running. So that way, if Azure does either an update or we have a node that fails or a rack that fails or whatever, the scheduler itself runs in an HA mode so that if one fails, it'll fall over. Everything keeps on running, which is great. So in there was two things going on. One was we published an application front end. So that was that website that I connected to where the phone was working. Where the phone was talking over a REST interface to here. But inside, you can actually make a website or a service that has your nice Windows front or your nice web front end. And then in that same instance, we have the Windows Azure Scheduler. So again, it's the HPC job scheduler. We call it Windows Azure Scheduler here. And that's a component that's part of the SP3 SDK for HPC. And then over here, we had, I would say, 1 to n compute nodes. So, depending on how much money you want to spend and how large they'll let you go, you can make this pretty big. Our limit right now, within a deployment, I think you're limited to 320 cores total. So, you can have quite a bit of devices or quite a few nodes or cores committed to this. Either, extra large times what? 60? I don't know what the number would be. I don't do math that quick. Or a lot of individual smalls or whatnot, but your total core count's limited to that 320. Again, on premise with a system, we can take a cluster up to 32,000 cores. So the scheduler itself is able to really scale up. It's just right now we only work within a single deployment. And at 12 cents an hour times 300, you're burning $30 an hour anyway. So you kind of want to be careful with that. So, and the other piece that's inside these things here is this node manager. So these blue boxes here are the two parts that are two of the things that we ship inside the HPC, this pack, this SP3 SDK. And then additionally, there's support stuff like the MPI layers, our runtimes and whatnot. But these are the two actual pieces of code that will be running all the time. And then application, that pink box is up to yourselves to actually put inside there. That's the actual code that you want to go run. Okay, so building a scheduler-enabled deployment, what you need to have or do. So first is you got to have your Azure subscription. Next is you want to have your application. And then you want to construct a package, and that package will have both the HPC bits with it, but then also your own bits. And then you'll customize it and deploy. Customize and deploy depends on what you're trying to do here. If you're building a service that people are going to connect to, probably not a lot of customization per se, but if it's something you'd want to redistribute and people could run as part of an application, an on-premise application that's going to burst up, you would want to be able to allow them to customize that. Everything from putting in their own subscription information to potentially like how large they'd want it to run, so they could scale it themselves, you know. And then customize and deploy. All right, so let's step out of here just for a bit here. Let me go over to here. Boom. Okay. So part of what will be in this beta that we're going to have, so at the end of the slides, I'll give everybody a location they can go to, because we are going to ship a beta of this software toward the end of September, are some scripts that make some of this a bit easier to get things going and running. So, and it's pretty simple here. Our goal is to make it so that you as developers can start working really quick with this. This isn't what you would ship your customers, but it allows you to get kind of jump start and get going fast. So, whoops. Hang on. Boom. There we go. So it starts by just being able to, you got to start with your subscription ID. It's a whole set of PowerShell scripts. We're going to run through it kind of quick. I'm going to hit the button at the end to tell it to go. But Azure being Azure and takes a little while to deploy, we'll hit the button. We'll kind of do the Julia Child's cooking show thing. I'm going to switch to something I've already got in the oven, pull it out, and we can look at it while it's running. So anyway, we're just going to run through these scripts. Is that font okay for people? Do you want it bigger? Let's go bigger. Let's see, properties, font, 18. How's that? Bigger? One more size up. 20. All right. Whoa. All right, so the first part is we got to get our certificate that we're going to use. This tool will automatically create, you can tell it to generate a new certificate, and it will do that. And it'll give you that certificate, and then you can go to the management portal and upload it. I've already got one in there, so I'm just going to use it. It's number 4. So it says Windows, right here it's Windows Azure Management Certificate. We're going to say go. And now, what the heck, we'll just do we'll hit number 1 here, which is an existing one that's going, or one that I created a little bit before. You don't have to do that. You hit 0 and type in a new name. Storage account, I already have one there, or I could have created a new one. And then use a SQL server that already exists. So let's go ahead and we'll use the top one, which is already there. Actually, we can let's see what happens. Bang, bang. Now it tells you what it's going to do. We're going to hit yes, and it's probably going to error out here. Oh, what's going on? Creating SQL Server. Boom. Okay, so now it's going to go off. We'll let it sit here for just a second. what's like, if you notice, like we didn't have to go to the portal to do much stuff at all. Everything's going to happen inside here. It's one thing I didn't note earlier is that we're using SQL Azure in order to maintain the state of the job scheduler. HPC has been built on top of SQL for 6+ years. SQL allows us to have a very high fidelity, high transaction rate scheduler. So let's just wait for this just for a second, and we'll see how much farther it goes. And then we'll do the cooking show trick. So how's everybody enjoying build? It's the last day. Bummed? Yeah, we didn't get any of those cool tablets, so I'm looking around on eBay to see if I can find one. Rumor is that Samsung's going to be making another run of them. So, and what's that? Yeah, I can take a question. If you wouldn't mind using the microphone, though, that way I won't get in trouble.
Where is the head node running? Is running on-prem or in the cloud?
In this case, everything's running in the cloud. So I'd rather step away from saying it's a head node, and more that it's HPC components that you can use to maybe create your own head node, because the Azure itself is managing the collection of nodes, where in the past HPC has had a head node that does all of that node management stuff. So this is more like we're putting those components up there so you can use them.
I see. So my on-prem laptop, which is accessing these compute nodes,
right?
Do I need to use Windows Azure Connect in order to do that?
No, you don't. So you can do everything that we're showing here with a straight Azure deployment without Azure Connect.
Okay.
So what we will expose back, so in our SP2 release, which was back in June, a new component that was in HPC SP2 was the REST interfaces, so that we have an HTTP interface that could be exposed within an on-premise cluster. We've taken that same component and made it available up in Azure, so that you can expose the HPC REST interface right out of an Azure deployment, and then talk REST over it from the internet or from on-premise,
right.
So you can control that job scheduler. And that's how the first demo we did, where we were doing from the Windows Phone up to our deployment. It was talking across the REST interfaces to start that job.
Great. Okay. Thanks.
Okay. So we're going to close this down now, and I want to go do one other thing here. So we're going to connect now up to. Whoops, didn't type that in right. Does everybody know the password? Boom. Okay, this worked. Oh, here we go. Configuring, boom. Okay, so what I've connected to right now is the rendering demo that we did with the phone. It's talking to this deployment. So this is a node up in Azure. This is effectively, quote, our head node. So it's the node that's got the scheduler running on it. And what we got going on here are a couple things. First is, and I cannot make the font bigger on this, I apologize. So this is the job console that people who are used to using HPC would see on premise. This is actually running up in Azure. Okay, so we're 100% in Azure right now. Additionally, we can go over here and we can do all of the, and I can make this font bigger, so I'll do that real quick. Font. Okay, hopefully that's good. So so we're just right here up in Azure, everything's happy. If we do job list, I don't actually have any active jobs list running right now, but if I say something like job list all, we'll see all the jobs that are in here, boom, a bunch of them are finished, oop, one failed, oops. We have some other demos that we can run, and we'll do that just toward the end. We can also do things like people, how many people have not used HPC Server in here before? Okay, so how many people have, if you haven't used HPC but have used a job scheduler before? A couple, okay. So again, so if I do this command here, node list, what we'll see here, these are other nodes. So these are the compute nodes in the deployment that are ready to do work. And we've given them nice little names like worker node 01. The max is the maximum number of processes, but it's really what we would look at as being the core count. So these were all, I think we've got, what, eight extra large nodes. So I've got a 64 core deployment, but we did them as extra large nodes. And right now they show being idle. So here's kind of a neat little trick for people who might do some work up there. You can say this little command, cluster on directory, let's see, yeah, why not C:\\. What this does is it's gone out now and it told each one of those compute nodes to run this command and gathered that feedback. So it's kind of an interesting little debugging tool when you've got your deployment up there in order to be able to do things to those nodes and actually get, tell them either to do copies, directories, or whatnot. Excuse me. So other clever little things here. When we did those jobs, so job list all, these are all the jobs that have run. If we look at job number 60, that was that remote command I just ran. But if we look at job 59, which was that image rendering, so now we can do things like view that job, 59. It'll tell us some very interesting things about it. So on here, what we're seeing is that, first of all, that's the ID. We knew that already. It's finished. It had a name. We gave it a name. It had an owner. So owner's kind of interesting here. So what we're doing is we don't have these nodes like connected to an Active Directory or whatnot, but the job scheduler itself is doing, we're installing usernames on each one of those nodes. So we actually went to every single node, put a username called admin, and we sync the password. So we can do like workgroup level authentication between those nodes. So we can actually add multiple usernames. So as you submit work into these systems, you can track it on a per user basis. Additionally, the type was batch. So there's different scheduling policies. So we just use the batch scheduler policy. We said 1 to star cores. So this was an auto scaling rule. Since this was a parametric job that had a whole bunch of little tasks in it, we said use as many cores as you could find available. Then it's telling us where it ran, current allocation 0, well, it's done. But then we actually get very good statistics around when it was submitted, when it started, when it finished, how much time it took, how long it waited in the queue, etc. And then going down here, I should have explained this better. In HPC, a job isn't necessarily work. A job describes an environment to do work in. So a job is then a container for tasks, and the tasks themselves are the actual work items to go do. This one in particular contained 40 tasks. So what we can do is actually look at one of those tasks. (59.1) and 59.1. This was a parametric task that we wanted to go run. If we look at it here, what we had here was, here's the command line. So it basically just ran this command here, and the little star there is going to get replaced as it does the steps from 1 to 40. That star will get replaced, so it'll be frame-1, frame-2, frame-3. Over here, this is our storage account. What's the...
that's actually a phone notification.
Oh, I'm sorry, phone notification channel. In the... Wenming did the demo code, so you could explain that part a little bit better. Do you want to take that now? After I'm done, okay. So, and then it's showing, so parametric 40 tasks. But now we can drill in a little bit farther and look at an individual instance of that. Here. And that went a little bit faster. Let's go up a little bit. We're looking at the output here. So here we see this was task ID 59.1.1. So this was instance 1 of task 1 within job 59. And the command line got replaced to be frame-0. And what's nice here is we see exactly the node that it was executed on, and we also can get the start and end time, how long it took, and some other details as well. And then here's the output when it would ran. So it was just running that command script. And we can see all of the different steps that went by in order to render that frame. Boom, 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 right on down. So now, what HPC will do, in addition to just running this, is it's monitoring all of this stuff as it's happening out on the cluster. So if this task was running, and for some reason it failed, either something happened within the actual program, it didn't copy, there was some, just what we say transient network error or whatnot, or that node actually failed, the HPC, the scheduler, the Azure scheduler notes that there was a problem. If, and by default, the setup for the job is to automatically retry work, it would then take that work and then go retry it on another node automatically and run it. Are there any questions? Anybody have any questions? Okay. Now, just for fun, we can also do a nice little trick here. So what I did is I took 59 and I just told it to do it again. And she's off and running. So, Wenming, did you want to talk a little bit more about the scripts and what happened with those?
Sure. So if we were actually to run this on a cluster, a physical cluster, the way it would work is that you would have a file share where that's all your input files are going to be. And you take each of these frames, and by just simply reading those in a UNC path, and grab a file and render that and put that output back to the UNC. If you didn't have a file share, in this case we don't. This is all entirely running on Azure. So the first step you'll have to do is to actually do a blob copy. Take a frame out of one of your blob storage, copy it onto your node. And the other thing that's interesting about Azure is that you don't necessarily have very high bandwidth as you're on-premise. So the copy process may take a bit longer. So what we do instead is we actually zip up each of the frames. So the frames on these rendering image formats are especially large. They're usually text files. So RenderMan is text file, Pavray is also text file. So these files can be compressed down to a 1:10 ratio. It's very easy for you to upload them from on-premise, and it's also very easy for you to copy them from the blob storage to the node that is working on the actual frame. So the third step you'll have to do is to actually take the frame and run Aquis over it. So Aquis is an open source free tool that you can use to do that reads RenderMan format. So you run that and to produce a TIFF file, or it's a TIFF file, and you take that TIFF file and then copy that over to the movie rendering service, which will combine all the frames and then finally produce a movie. So I added another step in here, which is to tell the little phone device that we'll send you a little toast message saying, okay, the frame is done, and it will essentially notify you over the phone, even with the application closed. So we have about 10 different samples that goes from running protein folding to a DNA matching to image rendering and also MPI. So we have those samples available on the MSDN Learning Center, and I also brought some memory sticks which I downloaded and copied them onto the memory stick for you to take home. So after the session, you can come up and grab that and try out these samples. So back to you, Greg.
Yeah, and just a note, these are like collector's items right here because these are from the former technical computing group at Microsoft before we got reorged through one of our big companies like to reorg all the time. So these have TC3 on them. So, I mean, nobody will have these. These are the coolest thing. And they're 4 gigabytes?
Yes, they're 4 gigabytes.
4 gigabytes, and they have a pretty red light at the end. So anyway, make sure you grab one of these as you leave. I think I've got a question.
Yeah, quick question. You're running the Azure is in a VM type mode with the HPC software on it, right?
Yeah.
The Azure things are VMs, correct? And
No, these are not VM. These are
native
worker
Azure.
roles.
These are all worker roles.
Okay.
So it'll support both worker roles and VMs.
Okay.
So it can go either way. Another question.
So this worker role, so HPC components actually pre-installed, or I need to actually do the startup?
You take them, yeah. So you'll get the components inside the SDK,
Yep.
and then you'll embed them within your package.
So I need to do a startup task to install these.
Yeah. So right now, so you would have to service the HPC bits within it.
Okay, thanks.
So
Yeah,
there are several ways you can install your bits. One is that you pre-package it with your CSPKG. And the second way is we have a utility that's really easy to use. It's called HPC pack. So what you do is you run HPC pack, which creates a zip file, and then you say HPC pack upload, and it will upload it onto your blob storage because blob storage are persistent and the nodes are not. And then the third step you run is an HPC sync clus run. Clus run is the command that essentially tells each of the nodes to run this command. So clus run HPC sync, you will have your application on all of the nodes. It's just simple 3 steps.
Okay, great.
So here's what I like to do, because I got this clock and it's ticking.
Okay, go ahead.
So I want to hit my final few slides, and then we can do another few minutes of Q&A. Okay, so Windows Azure Scheduler, what is it? A component in the HPC release coming up for ISVs to use to build PaaS. Maybe I haven't thrown these terms out, or SaaS. So either application bursting, where your app can burst directly up to Azure, or a service where you've built a website that has a workflow, it's computationally intensive. So these components are available for you to very quickly get things up and running within your deployment. It's the same job scheduler that we've been shipping the past year, same version 3 scheduler. So we have priority-based, first come, first serve. I didn't really show that, but you can say this job's highest priority. So like Wenming's jobs will always run before mine, or in your deployment or whatnot, you might have that type of thing you want to go do. That's really interesting for some people who have cost things that they want to stay within. So you schedule your more important work with a higher priority to get it done first, and then the lower priority stuff that it's not critical that it completes before you would take your deployment down. So we can take care of all that. There's preemption in there, all kinds of great stuff, and that last little thing, cluster run. Even if you're not building a big service or computational intensive service, the HPC job scheduler is an attractive thing to put into any deployment, in my humble opinion, because it gives you the ability to very easily reach out and talk to all the nodes that are running there and do operations to gather data potentially, or do maintenance tasks without having to write that stuff yourself. We'll take care of all of that. So benefits, again, no need to rewrite infrastructure. We focus on your application. Instead of having to build something potentially on Azure Queues and tables, or you're going to go SQL Azure, et cetera, step back. Don't go in that direction. We had an internal partner in our Microsoft Research who built this really excellent BLAST site, and BLAST being basic logical alignment search tool, which is used to do a lot of comparison of genetic data. He said he spent 12 weeks, and this was a year plus ago when they started doing it, 12 weeks, 3 months, building a scheduler that could run things for him, and 1 week on his actual code, his app. So we showed him this stuff. It's oh, you just saved me 3 months, and he still had other work to do, so they've migrated to use this. And additionally, a really great thing for him is he can actually take that same thing now and pretty much run it on-premise unchanged. There's a little bit of work to do to get the data in and out because the storage model is different between the two places, but the core code that's doing actually all of the searching and whatnot is pretty much the same. He was also using SQL, and that made it easy because SQL Azure and SQL on-premise are, when you're actually doing stuff to it, it's pretty much the same. Let's see. Yep, and using the same API, blah, blah, blah. Blah, blah. I'm not supposed to say blah, blah, but I will. We got Q&A coming up, so you guys can ask a lot more questions. Who would use it? You guys would. So totally everybody in this room. But again, for people doing packaged software, if you want to be taking advantage of compute resources that are up in Azure, it's a great resource. And then for people, again, building a website that's actually going to go do something, if it's any type of computational work, there are great benefits here. But even not, if it's not doing specific computational work, it's really a great thing to have running in the background because it's really not, it doesn't use a lot of resources, but it's not doing much in order to do maintenance and control things and whatnot. And then again, another plug for AIDS talk. If you do, say, have a website and you're generating log data and you're putting that out into each one of your nodes, having HPC installed within your service will allow you to do some pretty easy analytics of the type of activity your users are generating on your site. Okay, so resources. 3 things right here. The first one is the connect.microsoft.com HPC site. This is, if you want to use these bits, this is the place you need to go. So we will have up on there by the end of the month a beta of our upcoming SP3 SDK. It'll have all this stuff in there so you can start using it right away. Blogs, that is Wenming's blog, right?
Yes.
Yes, so that's got a whole bunch of samples on it. And then the last one is the Azure training course. And I'm going to skip out of here again for just a second and go over here. And this is this awesome website right here. So there's lots of samples. There's everything you need to get started with either doing an HPC on-premise cluster bursting up to now this upcoming technology where you can embed it. So great site. Okay, and I was told to put this slide in, and we really would like feedback and questions about technology stuff. You can go to the forums, but I'd love to get some session feedback as well. So when I go do this talk the next time, I know a bit more about what we should do. So, and now I have 7 minutes and 52 seconds to answer questions. Yes, I'll put the link slide back.
Yeah, so another thing on the training course is that the samples is meant for SP2, which is the burst scenario. You have the nodes that are sitting, or you have a machine, which is your HPC head node, that are sitting on-premise. And then the samples would work on both on-premise and also on Azure nodes. And what's interesting is that you wouldn't have to change very much of your code to use the same samples for the upcoming release of the Azure-only worker node. We didn't really have to change any of the code for it to work with the all-in cloud deployment. Okay, question.
I had a question regarding the rendering sample.
Yeah.
So I understand that the cluster jobs were generating the TIFF files. That was the output.
Yes.
And so you were mentioning that there was another piece that was assembling those TIFF files.
Together, yes.
So was that a separate service that was running, or what was it that was controlling the execution?
It's actually in a web role that's essentially packaged together with the portal. And we have the sample right there on the memory stick, which you can take home and take a look. And
so was it just watching that the blob storage for the TIFF files, or was it is it something that was controlled by the scheduler that was?
We tell it at the end. We tell it it's finished, and then you can go.
But you could do like within a job, you can construct a hierarchy or dependency between tasks. So there's other ways you could do it as well. So the way that was done was monitoring, and I think from a this is how you could do it kind of point of view of monitoring when my job's done, then go grab and do the render. But you could actually put task number 2, you can add more tasks to it, so such that when task 1 is done, task 2 would say, okay, now I'm going to go do that render.
Yeah, there's many ways you can do this, and we have dependencies on tasks as well.
Yeah, so you can create a dependency like task 2 can't start till task 1 is done. And the potential advantage of doing it that way is that if, say, you had lots of rendering jobs, as one job gets through creating the frames, and then what would happen is we would shrink down the allocation for that job, and then you would just have one node within that job that's doing the render of the movie. You can then start a second job, which will then start rendering. And like the goal of every good job scheduler is to make 100% utilization of all of your nodes. And by 100% utilization isn't just make sure that there's something there running, but literally we're looking at the CPU utilization to make sure that we've got everything pegged at 100%. So if everything's working really well, we are like heating up Azure. So we're keeping all those nodes going. I've got kind of a standing offer to my group. We've actually blown out data set, not an Azure data center. Azure's never had a problem like this, but we did a run of a supercomputing run where there's a list called the top 500 list, where people try to get their supercomputer on the top 500 list. And we did a run at NCSA about 3-4 years ago, and we took the system so far that we blew out the circuit breaker for the data center. We took like a whole building down because we were running the machines so fast. So, and I have a standing, like, I'll take anybody on my team out to lunch if they can do that to an Azure cluster. And we haven't done that yet, so it's kind of a bet between me and some of the Azure hardware guys. So it won't happen. So, or if it did happen, everything would be fine because it would just auto-recover and be great. But next question.
It is probably an extension to James's earlier question was that it can take VMs as well.
Yes.
And then, so I guess that would probably, if we were going to manage the VM and everything, it would go under VM role.
Yeah. So in that case, what you have to do is put the components inside your VM role that you upload.
Correct.
Right.
And on other sessions, I've heard that VM role is not a good way to do it, but nobody told me why. So if you could throw some light on that, that would be great.
Okay. So VM roles. VM roles as they exist today are in beta. So we're continuing to evaluate what we want to do with VMs. VMs in Azure are stateless. They're not stateful. So so the same as a worker role. When it fails, you're going to lose all of your state. So now a VM role though is attractive if you've got like a big application that has to be installed every time you bring up a worker role. It's a lot better just to put it right in that VM base image because then your startup will be faster. So it just, yeah, you got to kind of do the trade-offs, pros, cons, and decide what to do. So in the future, as I understand, we'll have state in VMs, but I don't know when that's going to happen. So
If I had my head node running on-prem, and then I have all my compute nodes running on Azure,
yep.
How do I actually add my compute nodes to the same domain as my head node?
So from like an Active Directory point of view?
Correct.
Today you don't. So in the future you will. So yeah, that's an upcoming feature from Azure.
I see. So today, if I had my head node running on-prem, that means I need to use kind of Windows Azure Connect to add my compute nodes.
Yeah, the best way to do that right now is to use Azure Connect. So that came out with the SP2 release. So if you're so an on-premise head node, and it's using and controlling Azure resources,
right.
You get Azure Connect enabled, and then you can do, like, say you want to access a file share or something back on premise. You'll have to, when you do the net use statement to actually do that SMB back and forth, you'll have to have the credentials on the line, and then you can. So you can get that connectivity, but you're not running within the 80 context actually out on those nodes.
Okay.
Yet.
Yep.
So
Thanks.
future.
So I think the better design would be that you have the whole head node and everything in the cloud. And in that case, where can you have like if you were to run the VM role, where would the storage be? Like where would you store all that stuff? Can you store to reduce the latency between copying from on-premise to the cloud?
Oh, okay, yeah. So either on-premise or the scenario you're talking about there. What you'll want to do is orchestrate a copy. So best thing to do is go put that data either in Azure Storage or to get to that data into Azure Storage and then onto a single node. It is possible to do SMB between nodes within a deployment if you configure Azure correctly. So yeah, you definitely want to get that data through that little thin pipe up there and then use the bigger pipe that exists within there to copy that data out.
Okay.
And by the way, I have like 20 seconds, but I'm not going to run away. But I need to get off the stage so the next person can come in. But go ahead and ask your question. We'll make that the last question. Then I want to hand out those thumb drives, and yeah, I'll hang out for as long as I need to.
Simple question. When we need to use native code between C++,
right?
We need to use VM role instead of the worker role.
Yep.
Yeah,
no. If you're
you're
saying is you're running native code, you can run it on a worker role. Worker roles are essentially bare Windows server boxes, and you can run anything on it. In fact, what you just saw, the advantage is that you don't have to build a VM and upload that. And what their deployment would simply have to do is to HPC package it into a zip, HPC pack upload it onto the blob storage where it's persistent, and then do an HPC sync using cluster run. So each of the nodes would actually have a copy of your application. So that's really convenient. There is no other vendors that will allow you to do something like this. So you're simply deploying your cluster without having to deal with a VM at all. And once you deploy them, you can install the software, or you can pre-configure your system with the CSPKG, so you can have your applications pre-configured, or you can use the HPC pack. And there's a third way which you can do this, which is run something called an X drive. You can mount your drives onto each of the nodes if you want to, but those are the things for you to explore. And you guys have.
And we're going to wrap.
More questions. Okay.
So.
Well, sure.
But I get the last word.
Are you doing something?
I'm going to get the last word, which is just to build on that. Yeah, no, I wasn't doing anything. The last part, because now they're getting really excited, they want me out of here, is that's one of the key things about this technology here, is that you don't really have to go build Azure services to go use Azure to go get something done. We're giving you basically all of the pieces you need in order to start something up in Azure. Just put your application, your XE up there, and you can go run it, okay? So you're not actually, you don't have to dive in. Now, some people will want to go build like an awesome website, awesome service, expose their own endpoint. Great, go for it. Even doing that though, using these components is going to make it much, much easier and take a huge burden off of you to get that work done within that deployment. So with that, we're going to end. And we have these wonderful thumb drives, collector's items. Please come up and grab one. And please go fill out the feedback. I'd really appreciate it. Thank you very much.